This is a video from Math 386, and it's on factoring. The directions say to factor each trinomial if possible. Now, let's go ahead and take a look at example 1. In example 1, we have 6a squared minus 11a plus 4. Now, to factor means to write as a product. So we're going to have the product of two what are called binomials, right? Now, notice how the 4 is positive and the coefficient of the middle term is negative. And so what that tells me is that the sign in between the terms are going to both be negative, okay? Now, this is the traditional way to factor. Take a look at 6a squared. We have two choices. We can write this as 6a times a, or we can write this as 3a times 2a. And with 4, we can write this as 4 times 1, and we can write this as 2 times 2. And our goal is to figure out which combination will work, okay? Now, what I'm going to do is start with 3a and 2a. So I'm going to put 3a in the first slot here and 2a in the second slot here. And remember, we're trying to figure out a combination so that when I smile, right, I'm going to get negative 11a back. Okay, so what I'm going to try is this first combination here. And so I can't put the 4 here. Do we know why? If I put a 4 in this spot, the problem is I would be able to factor out a 2, which would then tell me I have to factor out a 2 from the left-hand side, which I can't do. And so that's going to force that number to be a 1. And if that's a 1, that means this has to be a 4. And if we check, notice that negative 8a minus 3a is negative 11a. And we got exactly the middle term we wanted. And so therefore, 6a squared minus 11a plus 4 is 3a minus 4 times 2a minus 1. And that's how you do example 1. Let's take a look at example 2. Suppose I had 8h squared minus 2h minus 21. And so when I break this up into a product of two binomials, right, notice how the constant here is negative, which means the sign in the middle here has to be positive and the sign in the middle here has to be negative. So you have to have opposite signs, in other words. Now, go for the first term. We're going to look at 8h squared. So we have a couple of choices. We can write this as 8h times h, and we can write this as 4h times 2h. And then 21 can be written as 21 times 1, and we can have 7 times 3. And so I like to go for the smaller relative numbers. So I'm going to try 4h and 2h for my my guessing and checking, if you will. Okay? Now, remember the goal. You're trying to get a negative 2 in the middle for the coefficient of the middle term. Now, in your mind, right, we have to look at these factors. If I put a 7 here, notice that 4 times 7 is 28. That's really big, which makes me think that that can't be a 7. Well, if that can't be a 7, then what I'm going to do is put the 7 over here. Okay? Which means this was going to be forced into being a 3. Now we're going to smile and see if we get that middle term back. Now look, 7 times 2h is 14h, right? 4h times negative 3 is negative 12h. When I subtract those, I get a positive 2h. But I want a negative 2h. Now, what that cues me into is that I have to swap places with these signs. So in other words, this is going to be a negative here in between the 4h and the 7, and this is going to be a positive over here. And if you check, right, if we were to check that again, notice 12h minus 14h is negative 2h, and that's exactly what I wanted. So when I factor 8h squared minus 2h minus 21, I get 4h minus 7 times 2h plus 3. Example 3. Suppose we had 3m squared plus 14m plus 8, okay? And I need to factor. Now, the sign in the middle of these binomials have to both be positive. No choice. 3m squared is 3m times m. So you notice I'm factoring the first term. 8 can only be written as 8 times 1 and 4 times 2. That's it. And you want to pay attention to the coefficient of that middle term. That's important, and I'll explain why in a second. So when I put a 3m here and an m here, okay, in my mind, right, if I'm looking at that first breakdown for 8, if I put an 8 here, right, isn't 3 times 8 24? That's kind of big, right? And so there's no way that can be an 8. If I put an 8 here and a 1 over here, right, 8m plus 3m is 11m. And I didn't make that middle term, right? So I already know that combination doesn't work, which means I have to look at the 4 and the 2. And if I look at the 4 and the 2, I just happen to know that 4 times 3 is 12. And so I want the 4 here and the 2 over here. And so I'm done. 3m squared plus 14m plus 8 is 3m plus 2 times m plus 4. And that's how we break that down. Let's take a look at example 4. Suppose we had 15p squared plus 24p plus 8, okay? When I break this down, right, I have a product of two binomials. The sign in the middle of each binomial has to be positive. Now, let's take a look at 15p squared. We have a couple of choices. We have 15p times p, and we have 5p times 3p. And for 8, we have 8 times 1 and 4 times 2. That's it. And so what I'm going to do is I'm going to try 5p and 3p first. So I tend to try the smaller relative numbers. Now, in my mind, right, if I were to look at 8 times 1, right, if I put an 8 here, okay, and I'm trying to give you guys insight into how I'm thinking, right, isn't 8 times 3 24? And so the problem is I'm already at 24p, and so I'm too big, right? Even if I put the 8 over on the other side, 5 times 8 is 40. That's still too big. And so what that tells me is that the 8 and the 1 don't work. That just leaves me 4 and 2. And so my gut reaction is to put the 4 there and to put the 2 here. But we always have to check. Did that work? Now, let's take a look. If I take 20p and I add 6p, notice how I get 26p. That's not 24p. So that did not work. And in fact, if I switch these, if I put the 4 here and the 2 here, I claim that still doesn't work. So 12p plus 10p is 22p. Still no good. So what that told me is that 5p and 3p, that combination does not work at all. And so what does that mean? What that means is we have to look at 15p and p. And I'm going to show you how we can quickly eliminate that. Okay? All right, now, if I look at the 8 and the 1, right? Remember that I'm trying to get 24. There's no way that can be 8. Why? Because 15 times 8 is 120. It's too big. So I'm going to erase the 8 and put it over here and put the 1 here. But again, you always have to check. You always have to check. So notice that 15p plus 8p is 23p. No good. So it doesn't work. And so 8 and 1 doesn't work for this combination here. So we need to try 4 and 2. If I put a 4 here, in your mind, you should be thinking 4 times 15 is 60. That's bad, right? Because I'm trying to get 24 back. And if I put the 2 there, it still doesn't work because 2 times 15 is 30. And so none of these combinations work. And so the answer to example 4 is that it's prime. We can't break it down any further. Okay? So that's how we do example 4. This is an example of a polynomial or a trinomial that's prime. Okay. Let's take a look at this one. And we'll stop after this example here. Suppose I had 12s squared plus 11st minus 5t squared. Now, when I break this down, if we look at that third term, it's negative, which tells me the sign in the middle have to be, of each binomial, have to be opposites. Now, 12s squared is 12s times s. It's 6s times 2s, and then it's 4s times 3s. 5t squared is 5t times t. And so what I'm going to do is I'm going to try 4s and 3s. I always go for the smaller relative numbers. And so when I look at 5t and t, there's not much choice. If I put the 5t in that slot here, 5 times 4 is 20, and that's too big. And so what that tells me is I'm going to put the 5t here and the t over there. And if you smile, right, notice that 15st minus 4st is positive 11st. And that's what I wanted. And that's a good stopping point for this video. This is a video on factoring, and we looked at 5 examples of factoring trinomials. Okay. All right, thank you.